Hello everyone, I'm Nanling Jim. I'm one of the module tutors in this module, KV7006 Machine Learning. This is a new module, and during this module we will learn several topics in machine learning. So this video is about overview of the module, which gives you a very brief idea of what we are going to learn during this module. So I will make a pre-recorded video cover many of these topics. So which I will do is give you an idea in terms of the method itself, machine learning method itself, and the different type of machine learning methods. For example, supervised, unsupervised machine learning. Some of you already learned some methods in machine learning. For example, in our Northumbria undergraduate program, computer science, some students have already learned artificial neural networks. And in other modules, you may have already learned like regression, linear regression, etc. In Northumbria or other universities. And probably you already know decision trees, etc. So what I'm going to do is, instead of make a long video which covers several topics within one video, one lecture, I try to make a shorter video which each one cover one topic. So for example, if the agenda says we will learn linear regression, we will learn classification, we will learn naive-based classification, we will linear regression in one lecture, but some of you may already learn one or two of them. So in order to save your time, I break down each method to separate videos. For example, if you have already learned classification or decision tree, you don't need to watch that video again. For example, artificial neural network, you have already learned. So when I make that kind of video, you don't have to watch them. So make your life more flexible. So you don't need to go through the whole video then to find the particular topic you would like. So you are expected to have a smaller video, a shorter video, to cover different topics. Okay, now let's look at the overview. So in this module, you probably will already know linear regression, but we are going to cover it because it is very important machine learning techniques. It's a fundamental one. And also we will cover a little bit of math about machine learning. And also we will learn probability theory. So you probably already learned probability theory in your undergraduate modules. So we will need a little bit of probability theory in order to understand how different machine learning methods work. And the naive base, quite traditional way for classification. And also, what is the key idea of classification? For example, what kind of input for classification? What are the output for classification? And in the middle, what is the mechanism in order for us to classify objects or data into different classes or groups? And then how are we going to evaluate accuracy and other contingency table, etc. And then we will learn SVM and KNN. So I'll give individual explanation a little bit later. K-nearest neighborhood is more for grouping things together. It's quite different from traditional classification. And the decision tree and the random forest is both the way giving the class label we try to find a way to classify a new object. We will also learn deep learning. So for those who have already have some idea of deep learning, you will know it's very, very popular topics in recent years, which will give us, very advanced knowledge in terms of analyze complicated data in order to address big data, high-dimensional data, etc. So we will also learn unsupervised learning, for example, clustering, k-means, and also we will learn other technique on unsupervised learning. Different from supervised learning, unsupervised learning, normally they will have data which have no class label. So they don't know what is the class the data belong to. So no human expert has given us a class label into the data record. So they are just like all records, but we don't know what kind of classes are available for us to classify them. So normally we need additional, we need to group them into different groups. Normally depend on the distance between records of existing data. Dimensionality reduction, as we know, some of you have taken big data module. Dimensionality is a problem for big data. So this gives us a richness of data, but on the other hand, challenge us with the computational analysis power to analyze which data are more relevant to the question you want answered. For example, you already know linear regression, and you will know that, for example, if I want to predict something on the dependent variable, which is y, normally I have independent variable x1, x2, x3, or until x10. You will know that some variables are irrelevant to what you want to predict. For example, the typical or classic example in textbooks are the predicting housing price. So housing price is a variable which is independent on x1, x2, x3, depend on other variables. For example, we know location is very important, which is, you can assume it always very important independent variable to housing price. And also size of the house is also important. Obviously, normally the larger the house, the house will be more expensive. That is a bit common sense. But they may have other information in your data record, which probably not very relevant to the predicting the housing price. For example, how many residents in that street? Normally they probably wouldn't make much sense. If the street have more houses in that street, the house price will be more expensive. So you will know some data. In the end, you will find that linear regression, some variable have very high or heavy weights, but others have very low or almost near zero weights. And then you will know that such kind of variable which have very low weight will be almost irrelevant. So by doing so, you can remove some variable out of your linear regression model, probably improve your accuracy. Okay, this is just a very, very general idea of the reduction of dimensionality. But we have other formal techniques we could learn. Principal component analysis, for example, which is a very popular tools you can use to analyze which variable are more relevant to the problem. Okay, this is a very short and a brief introduction for the module, and then you will see we release a different video for different topics. Thank you very much.